Let's look at a practical application of mutations and how it has affected people with the example of sickle cell anemia. Sickle cell anemia is a trait where normal blood cells, the shape of normal blood cells is mutated and they look more like a sickle. You might remember kind of like a sickle is farm equipment that's used to cut wheat, and the hammer and sickle is the logo for this former Soviet Union. Anyways, the change in proteins changes the quaternary structure, and sickle cells are not able to hold oxygen as well as regular blood cells, and so that can be somewhat of a dangerous disease as you don't get enough oxygen in your body. However, as we look at it here, here's the chain of amino acids that is produced in the body, and you'll notice if you have one base substitution, it changes that one amino acid in the sequence. And that's the difference between a normal blood cell and a sickle cell. It's just that one base changing one amino acid affects the structure of the whole thing. So when it's replaced, Val replaces glue, and I don't remember the full names of those amino acids, and so that leads to these sickle-shaped blood cells instead of the round blood cells, which means there's less oxygen that can be held in the body. And this can also have some effects on kidneys as well. So what could happen is, if you have a person that's normal, and then maybe you get a mutation with sickle cell, well, that person dies out. And maybe you've got a carrier for sickle cell, so it's like half sickle cell here. So those, then this would be normal again. So these survive, the normal keeps surviving, and then any that have any hint of sickle cell end up dying out, and there are no more sickle cells in the population, and that mutation is unfavorable and normal cells will advance. Now you might wonder then, why would there still be sickle cell in the population? Does the mutation keep? Could be that it's actually beneficial in some ways. If you notice, sickle cell tends to be higher in African American populations and in other populations that tend to lie along the equator. So if we've got Africa here and you got South America here, there tends to be more sickle cell anemia along the equator. And you might go, why is that? Well, those sickle-shaped cells actually are beneficial in preventing malaria. Malaria is a disease where mosquitoes come by and they bite you and they inject this protozoan, and it lives in your blood cells and causes all sorts of pains. You can see headaches, fever, fatigue and pain, nausea, vomiting, enlarged spleen, chill sweating, and it can make you very sick and even lead to death. So if you have certain cells in your body that the protists can't survive in, the sickle cells, it actually makes you more apt to survive in an area where malaria is high and there's no other prevention for malaria. So one of the reasons why sickle cell tended to be more abundant in populations of African Americans and those from South American descent is because it was actually beneficial to them back in a time when we didn't have much prevention for malaria. Then these populations might have moved to America or to Europe, to North America, sorry, or Europe. And at this point, the sickle cell is no longer beneficial because malaria is not a problem. You don't have that tropical environment with all the mosquitoes carrying malaria, and they find it to be more of a hindrance than a benefit. So depending on where you are, sickle cell could actually be beneficial to some extent. I mean, obviously, getting less oxygen isn't great, but just being a carrier and having some of those cells can help. And in most of the time, when you're not in an area where malaria is prevalent, then sickle cell can be very harmful, and those without it will be more likely to survive and reproduce. And that will lead towards your units later on evolution and natural selection.